Okay, so this collection of videos is a tutorial on how to run a t-test in JASP. And this first video is going to be a review of what a t-test is. So when you think of t-test, think of two. So we use it to compare the means of two groups. We're going to talk about two different types of t-tests. So you have your between subjects t-test. This is where you have two separate groups of participants, one being exposed to condition A and the other being exposed to condition B. And you compare the means of some sort of outcome between these two groups, hoping that the effects of one of the conditions is changing the outcome. And within subjects is you have one group of participants and they're exposed to both conditions. So condition A and then condition B, and you compare the difference between condition A and condition B. So it's a statistical analysis where we're comparing the means of two different groups. Our null hypothesis, which is the assumption that our manipulation has no effect on the participant, would be that the mean of group A is equal to the mean of group B. So we don't want this. We want to reject the null hypothesis, and we want to support our alternative hypothesis. So this is saying that the means are not going to be equal. Hopefully, that's attributable to some sort of experimental manipulation. So the alternative hypothesis is that the mean of group A is not equal to the mean of group B. You can also think of this as the mean of group A minus the mean of group B does not equal 0. And to do this, we set our significance level to a p-value of less than 0.05. So when you're looking at your results, the first thing you need to do is look at your p-value. If it's less than 0.05, that means that we rejected the null. So that means that our hypothesis was supported and there is a difference between the two means. So what do we need to run a t-test? We need two things. We need an independent categorical variable, and it needs to have two levels. So condition A and condition B would be the two levels. So let's say you're looking at the effects of caffeine on study habits. Your two levels could be no caffeine and caffeine. And then you need a continuous dependent variable. So let's say we wanted to look at the effects of caffeine on exam grades. So our dependent variable would be exam grades ranging from 0 to 100, and hopefully the group that is given caffeine would have higher exam grades. So we would compare the means of the exam grades in the no caffeine group to the means of the exam grades in the caffeine group, and hopefully there would be a difference between those two means. So the example that we're going to run in JASP today is a fictional experiment that's provided in JASP's data library. So we are looking at the effects of invisibility cloaks on mischievous acts. So we have 24 participants, and we give half of them invisibility cloaks and the other half regular cloaks. And our hypothesis is that the group with the invisibility cloaks will perform more mischievous acts. So our dependent variable is mischievous acts, so the number of acts they perform in a week. And then our independent variable is the invisibility cloak, so the cloak group and the no cloak group. So we have 24 participants. We randomly assign them to each condition. So 12 of them will receive a cloak and 12 of them will not have a cloak. So our independent variable is whether or not they receive a cloak, and the levels are cloak versus no cloak. And then our dependent variable is continuous, and it's the number of mischievous acts that they commit in that week. So when we run an independent t-test, we make some assumptions about our data. So we assume that our data is normally distributed. Normally distributed around the mean, with some participants exhibiting more mischievous acts above the mean and some below, but most around the mean. We also assume independence, so that the levels of our independent variable are independent of one another, and we assume homogeneity of variance. So the variance of the dependent variable should be equal, so hopefully there's no outliers in our data. Um, so we want to check these after we run our t-test to make sure that we're meeting our assumptions, that there's nothing going wrong with our data. This will be particularly important if we do not get significant results, because that may be because there's something wonky going on in our data.